Properties of motion. In order to establish with complete exactitude the necessity for regarding the world as a world of 6 coordinates, it is necessary to examine the fundamental concepts of physics that have remained without definition. To see whether it might be possible to find definitions for them, with the help of some of the principles we have established thus far. We will deal with matter, space, motion, velocity, infinity, mass, light, and so on. To begin though with motion. In the usual views of both old and the new physics, motion remains always the same. Distinction is made only between its properties, duration, velocity, direction in space, discontinuity, continuity, periodicity, acceleration, retardation, and so on. The characteristics of these properties are attributed to motion itself, so that motion is divided into rectilinear, curvilinear, continuous, non-continuous, accelerated, retarded, etc. The principle of the relativity of motion led to the principle of the composition of velocities, and the working out of the principle of relativity led to the denial of the possibility of the composition of velocities, when terrestrial velocities are compared with the velocity of light. This led to many other conclusions, suppositions, and hypotheses, however these do not interest us for the moment. One fact however must be established, namely that the very concept motion is not defined. Equally, velocity is not defined, and with regard to light opinions of physicists diverge. For the present it is important only to realize that motion is always taken as a phenomenon of one kind. There are no attempts to establish different kinds of phenomenon in motion itself. This is particularly strange because for direct observation there definitely exist 4 kinds of motion, as for distinct phenomena. In certain cases direct observation deceives us, for example when it shows much non-existent motion. However, phenomena themselves are one thing, and the division of them is another. In this particular case direct observation brings us to real and unquestionable facts. One cannot reason about motion without having understood the division of motion into 4 kinds. These 4 kinds of motion are as follows. Slow motion, invisible as motion. For instance, the movement of the hour hand on a clock. Visible motion. Quick motion, when a point becomes a line, for instance the movement of a smoldering match, or glowing ember waved quickly in the dark. Motion, so quick that it does not leave any visual impression, but produces definite physical effects, for example the motion of a flying bullet. In order to understand the difference between the 4 kinds of motion, imagine for a moment a simple experiment. Visualize a white wall at a certain distance from us, on which a black point is moving, now faster, now slower, then stopping altogether. It is possible to determine exactly where we begin to see the point move, and when we cease to see it move. We see the movement of the point as movement if the point covers in 1/10 of a second, 1 or 2 minutes of the arc of a circle, taking as the radius our distance from the wall. If the point moves more slowly, it will appear to us motionless. Suppose first, that the point moves with the velocity of the hour hand of a clock. Then comparing its position with other motionless points, first we establish the fact of the movement of the point, and second we determine the velocity of its movement. However, we do not see the movement itself. This will be the first kind of motion, invisible motion. Further, if the point moves more quickly, covering 2 minutes of arc or more in 1/10 of a second, we see its motion as motion. This is the second kind of motion, visible motion. It can be varied in its character and cover a large scale of velocities, but when velocity is increased 4,000 to 5,000 times, and in certain cases less, it passes into the third kind of motion. This means that if the point moves very fast, covering in 1/10 of a second the whole field of our vision, i.e. 160 degrees or 9,600 minutes of arc, we shall see it not as a moving point, but as a line. This is the third kind of motion with a visible trace, or motion in which the moving point is transformed into a line, motion with the apparent addition of one dimension. Finally, if the point starts off at once with the velocity of say a rifle bullet, then we shall not see it at all. However, if the point possesses weight and mass, then its motion may have many physical effects that we can observe and study. For example, we could hear the motion, the crack of the bullet as it breaks the sound barrier. We could see other motions aroused by the invisible motion, disturbances in the air around the bullet, and so on. This is the fourth kind of motion, motion with an invisible but perceptible trace. These four kinds of motion are real facts upon which depend the whole form, aspect, and correlation of phenomena in our universe. This is so because the distinction of the four kinds of motion is not only subjective, i.e. they differ not only in our perception, but they differ physically in their results, and in their action on other phenomena. Above all, they are different in relation to one another, and this relation is permanent. The ideas that have been set forth here may appear very naive to a learned physicist. What is the eye, they would say. The eye has a strange capacity for remembering for about 1/10 of a second what it has seen. If the point moves sufficiently fast for the memory of each 1/10 of a second to merge with another memory, then the result will be a line. There is however no transformation of a point into a line here, as it is all entirely subjective, that is, it all takes place only in us, only in our perception. In reality, a moving point remains a moving point, and this is how the matter appears from a scientific point of view. The objection is based upon the supposition that we know that observed phenomena are produced by the motion of a point. But suppose we do not know. How can we ascertain it, if we cannot come sufficiently close to the line that we observe, or arrest the motion and stop the supposed moving point? Our eye sees a line. With a certain velocity of motion, a video camera will also see a line or streak. We've all seen speeded up film showing traffic moving at night along streets, captured as streaks of multicolored light on the screen. The moving point is actually transformed into a line, and we are quite wrong in not trusting our eye in this case. This is just a case in which our eye does not deceive us. The eye establishes an exact principle of division of velocities. The eye establishes these divisions for itself, on its own level and on its own scale. However, this scale may change. What will not change, for example in connection with the distance, and what will remain the same on any scale, is first the number of different kinds of motion. There will always be four. Then the interrelation of the four velocities with their derivatives, i.e. with their results, or the interrelation of the four kinds of motion. This interrelation between the four kinds of motion creates the whole visible world. The essence of this interrelation consists of the fact that one motion is not necessarily motion relative to another motion, but only if the velocities that are compared do not differ greatly from one another. Thus in the above example, the visible motion of the point on the wall is motion, in comparison both with invisible motion, and with motion fast enough to form a line. But it will not be motion in relation to a flying bullet, for which it will be immobility, just as the line formed by a swiftly moving point will be a line, and not motion for a slowly, invisibly, moving point. This can be formulated in the following way. Dividing motion into four kinds, according to the above principles we observe that motion is motion with increased or decreased velocity, only for kinds of motion that are near to one another, that is, within the limits of a definite correlation of velocities. Or to put it more precisely, within the limits of a certain definite increase or decrease of velocity, that can probably be determined exactly. More remote kinds of motion, i.e. motions with very different velocities, for instance, 4,000 or 5,000 times slower or faster than another, are for one another not motions of different velocity, but phenomena of a greater or lesser number of dimensions. But what is velocity? What is this mysterious property of motion that exists only in middle degrees and disappears in small or large degrees, thus subtracting or adding one dimension? So then what is motion itself? Motion is an apparent phenomenon dependent upon the extension of a body in the three dimensions of time. This means that every three-dimensional body possesses also three time dimensions that we do not see as such, and which we call the properties of motion or of existence. Our mind cannot embrace three dimensions in their entirety, as there exist no concepts that would express their essence in all their variety. For all existent time concepts express only one side, or one dimension each. Therefore the extension of three-dimensional bodies in the indefinable for us three dimensions of time, appears as motion with all of its properties. We stand in exactly the same position in relation to dimensions of time, as animals stand in relation to the third dimension of space. We looked previously at the perception of the third dimension by animals. All apparent movements are for them real. A house turns around when a horse runs past it, a tree jumps into the road. Even if an animal is motionless, and only examines an equally motionless object, this object begins to manifest strange movements. The animal's own body, even in the state of rest, may manifest for it many strange movements that our bodies do not manifest for us. Our relation to motion, and particularly to velocity, is very similar to this. Velocity can be a property of space. The sensation of a velocity may be the sensation of the penetration into our consciousness of one of the dimensions of a higher space unknown to us. Velocity can be regarded as an angle. This explains all the properties of velocity, particularly the fact that both great and small velocities cease to be velocities. An angle naturally has a limit, both in one direction and in the other. Imagine again a world of flat beings, and imagine these flat beings in the shape of squares, with their organs of perception situated on one side of the square. Call this percipient side A. Now imagine that the square is turned with its percipient side towards two figures, let us say, two triangles, ABC and DEF, in the position illustrated. Of the triangle ABC, it knows only the line AC, and this line is motionless for it. Of the triangle DEEF, it knows the lines DE and DF, which appear to it as one line, and these lines which go out of the field of its vision, must undoubtedly differ from the line AC, must possess some property that the line AC does not have. The square will call this property motion. If the square happens to meet the triangle GHI, the lines GH and GI will also be motion for it, but a slower motion. If the square meets the triangle JKL, the lines JK and JL will be a swifter motion. Finally, if the square meets lines almost perpendicular to its percipient side, like the lines MN and MO, then it will say that this is the limiting maximal velocity and that there can be no higher velocity. The idea of velocity as an angle makes not only clear but necessary, the idea of a limiting velocity beyond which there can exist no other velocity, and also the idea of the impossibility of an infinite velocity. Quite simply because an angle cannot be infinite, and must have a limit that can always be established and measured. So far, in all the examples given, velocity has been taken as uniform and unchangeable. However, on the basis of the same principle, it is easy to establish the meaning of acceleration, variable velocity and so on. Let us imagine the receding line PQ is not a straight line, but a line with an angle. The flat square being, in examining such a line from the point P, will see this line starting with one speed and then accelerating. The line ST will appear to it as a motion, alternately accelerated and retarded. Furthermore, lines with angles, curves of different kinds, lines lying at various or changing angles to the percipient side, will represent different kinds of velocity. Constant, variable, uniformly accelerated, uniformly retarded, periodically accelerated and retarded and so on. The essence of what has been said is that a line, receding at an angle will appear as motion only if it lies at angles of certain definite degrees. A line lying at a very small angle to a motionless line, which is parallel to the percipient side, would appear motionless. At a greater angle, it would appear as motion, and a line lying at an angle approaching the limit would appear something altogether different from motion. Therefore velocity is only the property of certain definite angles, and as the angle does not depend upon scale, it is quite possible that velocity is the only constant phenomenon in the universe. This principle is in no way changed by the alteration of the angles on a spherical surface, or for instance on the saddle-shaped surface used by Lobachevsky, in comparison with the angles on a flat surface, because for every kind of surface the angles will remain unchangeable. Angle K, small velocity, the beginning of motion. Angle L, greater velocity, visible motion. Angle M, limiting velocity, the end of motion.